what I really wanted to talk about today, obviously we talk about like some of the career transition stuff I just mentioned. Uh, but I guess what are some of the things I found in my own career as um, to me, what I think are some of the best practices around, I'm going to call it like something we refer to them as code smells, but especially what I think of as object oriented fundamentals, right? And typically a lot of the Salesforce, right, Apex code bases I've seen don't really use the power of Apex as an object oriented language, but a lot of the code bases I feel like don't really use that to its full power, right? We don't use the object oriented features of Apex and tend to write sometimes in a very procedural style. And sometimes that's good, sometimes it's not so good. And I think it can lead to really messy, hard to maintain code. So what we're going to really try to do today is I'm going to switch back and forth between my IDE and we're going to take a controller method, and I think this is fairly representative of something I feel like I could see. I don't know. No, great. Now I have it's not a hide. Um, we'll talk through it. I don't know why when I rebooted, like my symbol table is not loading. It doesn't realize it's part of a Salesforce project anymore. So everything keeps getting better. Um, I'm just going to try to do that real quick. Um, but I'm going to say fairly representative of, like a controller class I might see, right? So we are, kind of the idea being here, and, we're going to take something. It's always kind of a challenge, right? You want to make it simple enough that it makes an effective demonstration, but, not so simple it's kind of pointless to do. So kind of the idea being like we've got something where a user is going to, they're going to submit a payment, right? And we don't know until runtime, is that payment going to be a Visa, a MasterCard, a Discover? Maybe the business down the road wants to add support for, PayPal, Venmo, you name it. I don't know, cryptocurrency. So how do we do that? How do we make this flexible? So right now, this is what I'd say. Yeah, like we have a lot of conditional logic in here. Lots of parameters, lots of primitives, big pile of strings. And then we go down here, right? We're going to process this payment. And, again, we've got kind of the, if it's this, it's going to be a V, and then we're going to do this. And so anytime there's a change, right, we have to kind of break this open and we have to make modifications and potentially kind of disrupt the whole thing. So what we want to do is we're going to talk about how do we get from this to a controller method that looks more like this, right? And this is what I would say, and as a lead, like this is what I would want my controllers to look like, my presentation layer, as thin as possible, absolutely no business logic. So how do we do that? How do we get from point A to point B? So the things we're going to kind of talk about today to try to accomplish that. We're talking about the polymorphism in Apex. What does that mean? How do we use that? The concepts of programming to an interface and not an implementation is something you'll hear a lot. And that, frankly, like that used to, both of these actually used to really confuse the heck out of me. And primitive obsession. Also, I guess all of these used to really confuse me. And I picked primitive obsession because it's one of my favorite things in Martin Fowler's book, Refactoring, right? It's in his list of code smells. And I think it's a common one. It's probably one of the hardest ones to understand. So it's just one code smell we'll talk about today, and how do we deal with that? And so we're going to kind of take all of these things. How do we apply them in Apex in an everyday use case, and hopefully come up with a little more flexible, little stronger code. Also, guys, if there are questions along the way, let me know. I'm trying to glance over at the chat window from time to time, but I may miss it. So feel free to hop in and let me know, and I can stop anywhere along the way. So I do want to just see how okay, we're still rebuilding our symbol table. All right. So one of the things I want to talk about is polymorphism, and polymorphism, right? If for, is back to a Greek word of, many forms, many shapes, many types. Um, I think it's one of the most powerful features of an object-oriented language. Like it is to me like the great thing, and it allows us to add, but it's a big word and confusing, but it allows us to access objects of different types through the same interface. And then each type can have its own implementation of this interface. And there's really two kinds of polymorphism. So the first one I want to talk about, because I'm a fan of using this quite a bit, depending on the situation, is compile time polymorphism, um, or also referred to as method overloading. And this can be a really easy and I think good way sometimes to bulkify your code to make your methods a little more flexible. So I always think a good example, I'm going to open up my project window. And I actually took this code originally from James Simone's Joys of Apex blog, right? But this is a really good example of just a pattern that is using method over. And when we talk about method overloading, all we're saying is a method can have the same name, right? We've got two do inserts here, as long as they take different parameters. So our first do insert takes a single S object, and all it actually does down here is, right, it passes that off down to our second do insert that takes a list of S objects. So it's going to take that single record. So a lot of times if I'm building an API like this is the pattern that I'll go to, is this sort of overloading, because I do want to allow, the client code to have the option to pass in an individual item. But you also want to have that bulk. And method overloading really it's everywhere. So I'll just say if we just did, string S equals, string dot value of, I want to control space. So, so if people want to also, as an IDE, I like to use this is IntelliJ with Illuminated Cloud. A string.value of, right? That is a big overloaded method, right? Salesforce did that for us, right? You can pass in a data you can pass in any data type, the string.value of, and it will return back a string to you. So they are all over and really, really useful anytime you are building. I'm going to say, especially any kind of a library API where you want to allow that next developer that sort of flexibility in how they use your code. But that's method overloading, and we'll see that when we clean this up. And not to be confused, I'm going to say, with probably the more standard type of polymorphism, right? Which is, and we're going to see different examples of this today. Where we have your interfaces, your virtual classes, and your abstract classes, and also, right, abstract and virtual methods. So we're going to kind of get in. So first we're going to switch over and look at the code and see how do we start to bring some of these things in, and hopefully make this method a little bit cleaner. So we're going to switch over. And in the comments, I've just kind of written, like, here are the steps that I would take to work through this. So the first, usually typically my rule, step one, is remove that long parameter list and place it in its own object. And my own I took this from Bob Martin, right, in his book, Clean Code. And I try to have a rule for the most part. If I start to need more than 3 parameters, this probably needs to go into an object. And also what we're doing, I'm going to go back to our original one, is this is also an example of primitive obsession, right? So we have this whole concept that's really key to our code base of, I'm saying, really, this looks like a credit card. but we're not really representing it with a credit card object, something strongly typed like that contains its own logic. We are just representing it with a whole bunch of primitives, right? Just a bunch of strings and decimals. So what we're going to do, we're going to clean up this primitive obsession, and we are going to first clean up this long parameter list. So down here, I just created this little wrapper class, payment details. And I made it an inner class. Doesn't have to be. Just how I wrote it the morning I was working on this. Probably arguably better not. So there's no particular rhyme or reason for why this is an inner class, right? But it takes all those parameters and it just creates a payment details object for us. Very simple. And that's kind of how I guess I define a wrapper class is a class that has properties, but no methods, right? It stores and organizes data for me in some way, but doesn't do anything, doesn't act on that data. But we're going to clean that up, and we're now going to just turn that into an object that our payment system can use. So we've created our payment details. So now we took, and we're going to use this overloading. I'm saying maybe in one case we have, right, we're getting called from a community, Lightning Web Component, right? So it is going to pass us a big string. It's going to pass a big JSON string, right, to that Aura-enabled method. So we have this option, right? So we're just going to JSON.deserialize that. And down here, again, we use the method overloading. So we have if we wanted to access this controller from other places in our code, that could just directly instantiate a payment details. It can be called from this method. And then it just goes, so submit payment. So we've already, you can see, we've taken care of that parameter list by just putting it into its own object. And we're now going to kick all of that logic out of the controller and into a service layer. So we're going to go take a look at our payment service class. Looking over if there's any questions. All right, so here's our payment service, and you can see there's actually still not a lot going on here, but this is where we're going to start to see some of our first examples of, I'm going to say, probably the more powerful aspects of polymorphism, and we're going to start to bring in some design patterns. So the payment service class is using a few of what I think are the really powerful techniques in object-oriented programming. So I'm going to start with is composition. And I think a lot of times you may hear people say, prefer composition to inheritance. I think it depends on the use case, but the idea of composition is just that we have this object, we have our payment service object, right? And it is built with other objects. In this case, it's a credit card. And just to explain that, so we're going to go to our credit card. Credit card is an abstract class. All right. So what that means is if an abstract class cannot, if you're not familiar with it, right, it's an abstract data type. It cannot be instantiated directly, right? You cannot say, you know, credit card equals new credit card. That'll fail. That will not compile. What you have to do are then make what we call like concrete instances of, of credit card, concrete credit cards. So in this case, say we have a Visa or a Discover, right? And they extend credit card. And I'll just pause real quick. A common question I get here is, hey, you know, why did you use an abstract class instead of an interface or a virtual class? So abstract versus interface to me kind of comes down to, does this object need some kind of state? When a concrete version is created, right, does it need member properties? Does it need to know something about its world? And so in this case, yes, right, because our credit card abstract class is actually going to take a payment details object, right? So all those details that we created earlier, right, you know, the amount, the card number, the expiration date, right, it's going to take those into its constructor. So I need a constructor. So an interface is not really going to work for me. This could have been a virtual class and really probably worked just as well. But in my own design decision, I'm thinking, hey, I never actually want somebody to call new credit card. I only want a new Visa. I only want a new Discover. So that is why I usually, and I think I just generally prefer abstract to virtual classes. So that's why we have this abstract credit card. And back in our service, so what this means, and the polymorphic behavior is on the left, we have the type of credit card, but that type can now be assigned anything that, extends credit card. So we've made these concrete credit cards, our Visa, our Discover, our MasterCard. Any one of those at runtime can be assigned to this credit card property. And this becomes, like I said, really powerful because we don't know until runtime, what do we need? And I think this becomes much more flexible and much easier to maintain than lots of complicated conditional logic. So what we do then is we're going to use dependency injection to give us the correct version of the correct version of our credit card type at runtime. So in our constructor, right, we take this payment details object in, and we are going to call this little credit card factory with a get instance method, and we're going to pass it in. So we're going to continue using that payment details object. So let's go take a look at our get instance. Simple switch statement here, just to make it nice and easy and readable, right? So it's just going to take that value. So payment details has a card type, right? A payment type. And depending on what it receives, it's going to pass out, right, the correct instance of a credit card. Because it's important right here, our factory method does not return, a concrete type. It doesn't return a Visa or a MasterCard. It returns this abstract credit card. But because everything in our factory, right, all these concrete credit cards that it's instantiating, all extend credit card, this works. So with one line, right, we can go back to our payment service. We say, hey, now we know at runtime, depending on what the user picked, right, we are going to get the correct card that implements the logic that we want for our payment service. And then we go down here, we have this process order method, and we're going to delegate that out. Because again, I would argue from an object-oriented, right, analysis and design point of view that how the payment is actually processed, again, doesn't belong in the service layer. It belongs in that concrete credit card. So what we're really kind of doing also at this point is, this is one of my favorite of the classic design patterns. And when I tell you, like, I'm referring to a book, if you're not familiar with it, called Design Patterns by the group of authors called the Gang of Four. There's also a really excellent book that I think every Salesforce developer should own called Apex Design Patterns, that is just great examples of implementations of these designs in Apex. So what we're really doing here is we're kind of building a strategy pattern. And a strategy pattern is just a way of saying, hey, we're going to use some composition and we're going to use some polymorphism to implement the correct algorithm, out of a family of algorithms at runtime. We don't know what we want to implement until runtime. So the strategy pattern lets us solve that problem. So now what we want to do, we have instantiated the correct type of card, a Visa, a MasterCard, a Discover. We did that at runtime, right? So we're using dependency injection, right? So instead of saying, like this equals new, we're saying, just inject in at runtime what we need. And then we have our service layer has the process order method, but it's actually delegating that out to the card type. So if we go back and we take a look at how are we going to do this next step, first, I would just want to bounce back to our slides real quick. And I wanted to call this out because I think this is an important part of understanding object-oriented programming, and some of the things is programming to an interface. And this is kind of what we're trying to do now. Is originally in our original code, right? That original controller we looked at with the, if we were really programming to implementations. Programming to an interface is essentially a way of saying, hey, program to an abstract type. And it can be confusing. I think sometimes this really confused me at first, especially because languages like Java or Apex give you an interface data type. And it doesn't mean use an interface, right? Like, the interface data type. It means, and just any form of abstraction. So in our case, that could be virtual, that could be abstract, that could be an interface, depending on what is appropriate for you for that particular problem, right? So what we're really talking about is how do we program to a super type? And I think that the strategy pattern is just, and that's kind of what we're working on now, is just a really phenomenal example of that. And we're going to, so when we go back, so now if we take a look at our credit cards, or not our credit card class, right? Our abstract class. There's a few things going on here that give us, so we have a constructor, right? And we're going to take in those details. Then there's a couple different techniques at play here. I declared two methods abstract: verify card and process payment. And I made them protected. So the protected keyword is just giving access to these methods to all the children. Every concrete credit card will have access to that. And because they're abstract, I'm saying any class that extends credit card must implement verify card. You must implement process payment. So if I tried to do a Visa and comment that out real quick. All right, boom. And I'm going to get that red squiggly right away. This won't compile if I try it again. So it's a little bit of, right, we're going to kind of work. Basically, I always say, like, we're creating a contract. We're saying anything that is type credit card, you, the client, the user, like we're developing, we have a contract that we are going to provide you these methods, right? These methods have verify card and process payment. Something I threw in at the end, because I wanted to provide, there's also a virtual method here. And what this can let us do is implement a template pattern. And the template pattern, if anybody has used FFlib, if you are familiar with the Apex Commons library, the template pattern is everywhere. The whole unit of work is one big template pattern. So what that means, right? So we're saying, hey, we have our two abstract methods, saying everybody has to, and this is the design of it, like, these are required. You must implement these. This virtual method, it's not required, right? It's this empty method. In fact, I'd even do it like that, make it a little more fun. Empty method. If you want to, if you need to validate address, you can implement that and override it. And then in our public method, right? This is the method that our actual, our service layer actually is going to access, the submit payment. All of these methods are called. And this is, again, you'll see this a lot like the unit of work pattern. There's the commit work, I think, or do commit, whatever it is. And it has all of these, before insert, after, and you can go ahead and, if you need to, implement those on your own. But this one, right, so this is going to call all of those methods. So let's go take a look at our Visa. In fact, let's take a look at MasterCard first, because that has all of them. MasterCard, we overrode our validate address. All right, so we did implement that for MasterCard. So let's say that was kind of our use case. MasterCard, for whatever reason, has to do that. The other two do not. Each one of these now has its own verify credit card algorithm, say, where we're just checking that the card number was the right length. right? So, this case had, that has to be 11. And then we are going to, right, process payment, right? This would be maybe our HTTP call out, something like that. So MasterCard can implement its payment logic in its own way, while, Visa, right, is not going to say implement verify address because it, for whatever reason, right now doesn't need it. Um, it is going to implement its own logic for how to we validate that this is a correct card number. And then it's going to make its own call out to process the payment. And if something does go wrong, right, they all have access to the credit card. So this is something I typically tend to do is, especially when I create these sort of abstract type classes, is create my own custom exception. If something goes wrong, it's going to throw a credit card exception that the user can then use. So I'm going to take a look over here, see if there's any questions. So no, it is not mandatory to implement the virtual method. And that's kind of one of the reasons I went with, just to demonstrate that. So if we go to our credit card, right, it is mandatory. Anything that is going to extend credit card must implement the abstract methods. Validate address, you just leave it like that. Just leave it as an empty method like that. So abstract methods do have to be implemented. It's kind of like using an interface, right? They have to be done that way. And I mean, yes, you could do validation for all three. I think if I understand it correctly, to combine them. But I would say it's not what you want to do, right? Because if that's kind of what we had in our earlier controller, right? And a lot, if it's this, do this, if it's that. So one of the things, and now that I have it, I'm going to give a quick example of, we're going to run PMD on this. And I wanted to do this at the beginning, but I couldn't because I had to reboot my editor. So if you're not familiar with PMD, is a really, really powerful static code analysis tool. And I'm just catching the time that we are. So we are going to inspect code. We're just going to inspect this particular method. I'm going to use PMD. Run a little slower than it normally would today. So one of the, okay, so we're going to go to our PMD, and there's a few things, but what I want to call out is this one, cyclomatic complexity. We've got basically, because the method submit payment has a cyclomatic complexity of 13. So cyclomatic complexity, if you're not familiar with it, is actually, it's kind of a graph algorithm, but a mathematical way to represent kind of like how complicated your code is, right? And it's really looking at how many paths there are through. And if you want to quickly blow up your cyclomatic complexity, the fastest way to do it is a lot of conditional logic. Ifs, we see we've got nested ifs, then else ifs, and you know what I mean? If we started to stick some ands and ors and, all the crazy stuff we have all seen, like this would hit 20, 30 really fast. And especially once you cross that 10 number, and I mean, as a lead developer, I'll say this, that's kind of my, if it's a 10, we're going to go back and refactor. To me, a 10 means that method should probably have been at least 2, if not 3 different methods. So because the higher your complexity is, the harder your code becomes to test, the easier it becomes for bugs to hide in it. And also the harder it gets to be for the next developer to understand it. And I'll say, I'll speak certainly for me, and I think this is for most developers, I find absolutely the hardest thing to reason about when I'm looking at somebody else's code or even the code I wrote last week is conditional logic, right? If there are lots of nested ifs and the ands and ors, it becomes really, really hard to look at that and reason about it. So one of the things that polymorphism, and in this case, like the strategy pattern, let us do is break all of that up and give that kind of validation, these payment processing tools, to the place where they really belong, right? They don't belong in the controller. I would argue they don't belong in the service class. Um, they belong in the appropriate concrete instance of, in this case, a credit card. And that lets us control the complexity of our code. And now we have these nice, simple methods that do one thing, right? I'm a firm believer, right? Like if methods, if at all possible, I mean, should never be longer than 10 lines. I like to keep mine under 10. If I can write one-line methods, I feel like it's a beautiful thing. And I'm not saying, obviously, that we never use conditional logic, but I really do. I guess in my own design, in my own day-to-day, like try to think about how can I control this and how can I make this as simple as possible. Uh, That's a good question about the ternary operator. And I'm going to tell you what, I'm going to guess, and I like ternary operators, to be clear. I've never actually really tested it against PMD to see if it would make a difference, which is an interesting question. Um, so I don't know. I do like to use them though, just for the sake of this demonstration where I wanted to keep things as simple and reasonable as possible. I didn't use any, but great question. I'm curious about it. I don't think it would make a difference though, because those are still different paths through your code. So I'm going to say I'm kind of looking at, so but that is kind of in everything I wanted to go over. So if anybody has questions, I'm happy to talk about them, because I said, and I guess I'll just kind of run over again the kind of the high level things that I I wanted everybody to take, and things that I feel like have really made a difference to me. Um, because I'm going to say right now, I don't like this code at all. Like I would not let this pass a code review. It is 100% the code I would have written 5 years ago. 100%. I would have done this times 10. I would have, had a, right, or this and, and that, and there would have been no limits. And everything I did would have been in one big, what I call God class. But I say I did that, and I always thought, hey, you know what? Thought I knew Apex was an object-oriented language. So I assumed I was doing object-oriented programming. I was not, right? I was to do object-oriented programming, fundamentally, you must be making use of objects. And I feel like as for my own career, um, starting to understand that. And the reason I call out primitive obsession is because that was one of the things that it took me a long time to understand, right? When I saw it in one of Martin Fowler's books, and I was like, oh, I looked up the definition, right? It's when we use primitives to represent core concepts of our code base. And kind of thought, well, what else would you use? Because I apparently, at that point, didn't really have a strong enough understanding of how we could start to take these things and model them as objects, right? That I didn't just have to use, the objects and the data types that Salesforce had given me, that I could create and build whatever I wanted. So these were all things that really, I think, helped me, I think, progress to kind of that next level. I think in my career, I still certainly try to learn every day, and I feel like I have a long way to go. But this, I think, really, really made a big difference for me. And I will say, like, obviously, like if this was a real controller. There'll probably also be some SOQL, some DML going on in there. Um, I excluded that for today just to keep things simple. That said, I do tend to also believe that inline DML, right, that inline SOQL are the devil. They very tightly couple your methods to the database. And usually I will handle my DML and my SOQL, right, also through composition and dependency injection and some other class like this, right, where I'm just going to pass my DML off to this DML object. And then I can mock that in my tests. And I don't have everything so tightly coupled and bound up, because we've all seen that apex where, you seems like you're trying to write a test for whatever method it is, and you insert an account, and it seems like that somehow touched your entire code base. So using dependency injection also, right, is a great tool for letting you do and introduce some mocking into your test classes. And yes, actually, everything is in a repo, and I'll provide the link after so everybody can have it. It's for those. I also run a YouTube channel that I call Software Engineering and Salesforce, and so this is one of the repo. It's in my repo that I use, where I store examples of design patterns. Let me see. Code convention to follow for Apex. I actually don't know those code conventions. So I've never heard of them. So I don't have a good answer there. That's something I have to learn. Is the strategy pattern similar to the factory pattern? Great question. So let me go over. So the factory pattern is a creational pattern. So if we go and first, this is our card factory, and I called it a card factory. If you go look up, right, gang of four factory, this is not it. I think a lot of times as developers, we tend to refer to factory as anything that just creates objects for us. But at a high level, that's what factories do. Factories create objects, and we go to those to control how objects are created. The strategy pattern is, so if we go back to our payment service, strategy pattern, I heard once somebody told me, and I think it's true, is a fancy way of saying like use composition. All right. So because we are using, all right, so we're using our factory to create a credit card. So because the factory pattern is an object creational pattern. Strategy is a behavioral pattern. There's creational, structural, and behavioral. And I believe strategy, without looking it up, is a behavioral pattern. Tell our objects how to behave, how to communicate. So in this case, we used one pattern to create our object. And then, so we have composition, and I meant to hit on this. So composition is the rule of thumb. So is a has a versus a is a. So this is different than inheritance. And there's a typo in my comment here. A Visa card is a credit. A Visa is a credit card. All right. So we use inheritance when something has an is a relationship. Right. So we have credit card and we have Visa. So we're using inheritance there. Visa is a credit card. Payment service is going to use composition, which is to how we model a has a relationship. Right. So payment service is not a credit card, but it does have a credit card. So then we can take that by getting the correct card at runtime, and each one of these cards defines, obviously our algorithms are mostly some debug statements. They define their algorithms individually. We can now choose from the correct family of a group of algorithms at runtime. So that's the difference between a factory and a strategy. But they are some of my favorites. Like I'm probably pull these patterns out of my pocket once a week for something. And one of the things I really have also come to appreciate about design patterns is it allows developers to have, a shared vocabulary. So if you can say, hey, I'm trying to, use a factory here, I'm trying to use a singleton here, other developers will, understand, what it is you're trying to build and create. Take a look. All right. So really, excellent questions. Oh, wow, we're already at 40 some minutes. Does anybody else have anything? This has really been fun.
Brooks, I had a question. I tried to,
Yeah.
I tried to talk to you so that I can express myself. So I just tried to implement the abstract
Mhm.
effect things here in a trigger handler class, right?
Mhm.
But later I realized that I need to actually get the methods in. I mean, I need to reuse that method that I have built from an invocable method from flows, right? So I had to go to the static methods, static things, right? So what is your suggestion? How would I actually build those two things out of here? Or is that, I mean, you know what I mean?
Um,
So I cannot do the static things here, right?
no, no, you cannot.
Yeah.
Um, so what I'm gonna guess is, um, and remember, I did want to. I'll show something in Anonymous Apex. Is you. So first, I would say like I avoid flows like anything. Like we just like the projects I'm on. We just don't do them. Right? It's Apex or nothing. So I think I've written one invocable method in my career and lived to regret it. Um, if I did have, um, so what I'm going to guess is probably something like you're going to need, like here in our controller, right? That's a static method. It has to be, right? Because we want to provide that. I didn't put Aura enabled on there, but right, we'd want a Lightning Web component to have access to this submit payment. Um, and then your static method. So in this case, probably whatever you have that's invocable
Mm,
from your flow would probably just do something similar, right? It's going to instantiate the object it needs and pass it off. That's
mm.
kind of what I'm thinking without seeing the code and fully admitting my ignorance. Don't tell Mark Benioff, right? I know he's never gonna invite me to anything, but yeah, I'm kind of death before flows.
No problem. I can understand. Yeah. Thanks.
Of course. And last thing, I guess I felt like I should prove this all works, and I never did that. Is let me get to my anonymous Apex. Right. So just to, like an example, so we have here, right? We've just quick anonymous Apex, right? We've got a Discover, we've got a MasterCard, and we've got a Visa. Um, and the Visa is going to blow up on us, right? Because we have a 4-digit credit card number in there. But if we run this, it should all work. So I'm going to just click debug only, go down, and right, we can see we verified the Discover card. We processed a payment for Discover for $1.99. MasterCard also, did that address verification because it had that additional method. And then we got down to Visa, and Visa blew up and threw a custom credit card exception at us. So, right, because in our controller, right, that's an Aura handled exception, right? That would get passed back up to the user like But yes, it does actually. It does all work. But I really, it's a lot to take in if you're not used to doing this. And I also think that this can be a good example. The common criticism with OO, because there are obviously I'm an OO advocate. There's people that hate it. Is that it can be hard to figure out where stuff actually happens, right? Because if I'm new to this code base, I'm like, oh, okay, well, submit payment, right? So that I got to go down to here. Okay, that goes to this service class. The service class, right? Like that still doesn't do it. Like that's forwarding. So object-oriented programming has this kind of design of forwarding things on to the object where we feel like it belongs. Um, but it can lead to, and I think I'm sure Visual Studio Code has the same sort of thing, but um, sometimes when you're in a new code base, it can be sometimes challenging, I think, to figure out where does stuff happen. Um, and IntelliJ, I get very good at hitting Control B to just take me to the next, the next, where let me go see this class. Okay, that forwards it on. Control B, take me to the next one. But that's, I would say, is probably the knock or the complaint that people sometimes have against OO.
Hey, bro. I have a simple questions if you have
Sure.
time. Yeah, this is very good object-oriented programming, but to my experience, when we deal with Salesforce limits like SQL or DML, or I mean, as per my experience, the biggest challenge of Salesforce Apex coding is to deal with limits.
Mm-hmm.
So when we do follow these sales object-oriented best practices, we generally we faces those limit issues because, for example, if we do the DML and SQL in inner class and inner method, and we call that from another object and do that operations from parent object calling object, then we see that those methods, if we call several times, then it goes to the limit of that SQLs and DML issues. So do you have
Mm-hmm.
any suggestions to overcome those issues? Thank you.
That's a great question. So I'm going to say typically for DML is I would I think DML you just have to whatever design you're going to use, and I don't think it's necessarily OO that is going to cause you issues with limits. It's generally just going to be your design got a little weird, right? So I don't know, maybe you instantiated a group of objects and each one of those objects ran a query that only needed to run once, something like that. Um, so it's I'm saying I don't think that's necessarily an OO limitation. Right? I can't think of how that would just cause that. With DML though, what I would say is you probably don't want, like, I probably wouldn't want my DML to happen, you know, in the credit card or something, right? That maybe is at the end of all the transactions. That might be more of a time for some sort of a unit of work. Um, but I don't have any good examples because I didn't want to kind of go outside of the scope of this and just start because I feel like DML and SOAP will kind of become their own whole separate conversations.
Okay, thank you.
Sorry, my throat's a little. So I guess I don't have a good example, but I feel like it's not necessarily a problem. I feel like I've run into too often.
Yeah, agree. We need to keep those things in our mind when we start designing all the our system, all
Yeah.
these object oriented. methodologies, and keep in mind that we cannot DML or SQL in such a method where it can be called several times or from a loop or something like that. So yeah, those things can be we should keep in mind. That's what I was asking. Do you have any suggestions regarding those? Thank you for your answer.
Well, so not necessarily a solution that I sometimes. So again, to another, it's not related to this one or this example I just gave, but what can be good sometimes to control. I'm gonna say, especially with SOQL, I use is singletons. Um, so I don't know, like I have the idea with the singleton, right? Is I have an object, and when this object gets created, SOQL has to be run. Um, but so what I want to make sure is that that object if doesn't get created more than once. If in this case, like if all we need is like this list of leads, right? Um, if other things in our code base are getting the list of hot leads, down here, I don't want, right? It's the same list. I don't want people instantiating that object time after time after time and burning another SOQL query. So the singleton is actually just a pattern, right? Where the constructor, here's kind of the defining thing of a singleton, has a private constructor. So nobody else can actually access, nobody can just say, give me a new hot lead singleton, right? And that constructor runs that query, but we've made it private. Singletons usually have something, I usually name it like get instance. And up here we have our hot lead singleton. And if it's null, if there's nothing there, we're gonna create a new one. We're gonna use the new keyword and we're gonna run our SOQL query. But otherwise, right, we're just going to give that back to you. So no matter how many times in our code base, maybe somebody said, hey, I need the list of hot leads. We are never going to instantiate that object and we're never going to run that SOQL query more than one time. So the singleton, can definitely be a useful pattern for something
It's
like
very, very good idea, actually. Yeah, thank you.
that. No, thank you. I kind of was like, yeah, that's just, so,
Yeah, I have a question, Shagir.
yeah.
So, in this design pattern, let's say in a batch job, I want to process 200 person credit card, let's say monthly subscription. That is why I want to process. So, it will call 200 records at a time and do the processing based on the credit card information, Visa, MasterCard, or Discover, whatever it is. So, if I run this from a batch, will it go to the call out limit like 101 or something like that?
Um, Probably. I knew so, like when I was making this up, I just kind of stuck the HTTP methods in there as an example. So I do want to be like not everything is just that you see is like super bulletproof production code. This is kind of me sitting down making some very simple examples this morning. But yeah, that probably would if you ran it that way. In that case, right? I mean, so what we in a real production version of this. What I would this would probably be actually a list of credit cards, and the and we could just and we would process the list, but to your point, I mean, what I would have to know, because I said I just kind of put the HTTP stuff in there just as a demo, right? Is this if we were calling an external service, right, where call out limits were concerned, do they have a bulk API, right? Can I give you 100 credit cards, right? If not, right, we would have to come up with a different design. But so again, this is kind of I'm going to say the challenge of any of these is you're trying to come up with something that's somewhat complicated enough that it's not totally trivial, but simple enough that it still makes a good presentation and is easy to understand. So in that case, I think a lot would really hinge around like, would this really work in that case? Is there a bulk API with the payment service? But I don't know. Does that make sense or answer your question, or I guess how I would approach it?
I think, yeah, so maybe we can reduce the batch job size to 5 or 10 to do this strategy pattern work properly. Or else we can use the bulk API payment method from PayPal or some others API providers. So that will handle the scenario. Yeah, that makes sense to me. Thank you.
Hi, Brooks.
Yeah.
I have a question. If we use clear method in list, set, or map, is it really free the memory like other programming language? As we know, the Apex learn in cloud base. So if we use clear method in list, set, or map in Apex, is it free the memory?
If we're talking about like, you say like, would like garbage collection pick up that object? So I'm not sure if I understood the question. Are you saying like if I had a list of integers and I called list.clear, like would garbage collection pick it up?
Yeah, like garbage collection.
I don't know if clear would do that or not. Typically, I guess the thing I always learned from Java is if I wanted to help out garbage collection, right? Like after I'd gotten rid of something would be just to set it to null, right? Get rid of any references.
Okay, all right. Thank you, everyone. So I think we can finish our question and answer session. And Brooks, and is this are you end of this session?
I am, yeah, absolutely. If nobody else, yes. Some really great questions. That's actually my favorite part is I always learn something or something I didn't think of. So if you're ready, I'm happy I can stop sharing and turn it back over to you, Mohammed.
Well, okay, and Brooks, and our audience is asking for your source code to share GitHub or also for
one second.
Also the suggestion for learning any books, ebooks or paper books, so you can share with us or you can send me. I will share to our community. Then this will be helpful for further.
Yeah, I'm gonna put I'm opening up my GitHub now and I'll put that link in the chat and then I'll get you kind of my list of books that really helped me.
That's good.
But that was, it was one of the reasons I started making YouTube videos is because like I didn't understand this stuff and I felt like there weren't very good like interfaces blew my mind. Like I did not understand why would anybody want an interface? Why would you want methods without method bodies? Because I didn't understand how polymorphism worked. And that's kind of why I started making these videos. I realized there's just no good examples of how this worked in Apex. But yes, I'm pulling up my GitHub link now and I'll get that one to the group.
Yeah, okay. I think we can start the quiz session.
Yes, Mehdi, you can take over this for this quick session. Meanwhile, Brooks can share the GitHub link and related.
Yeah, don't wait for me, please.
Okay, sure. Okay,
Yes, okay. So
carry on. You carry on the main.
So is my screen visible?
Yes.
Yeah. Okay, thank you. So you can scan the code and join in the quiz. Also, you can copy copy the link and paste it in your browser. So join it.
I'm unable to copy it.
Or you, okay, there the link is shared. Just you can maybe you can share again. I think maybe already shared the quiz link. Maybe you can
Yeah,
share
yes, I have
again.
shared once.
Can you put this on chat group?
Okay, everyone please join in the quiz. We'll be starting the quiz within 2 minutes.
It is asking me if I want to finish Q&A. Should I click yes or no on that, or am I on did I get on the wrong screen?
Okay, thanks. I can see you have shared the GitHub. Yes, I am. I can open your links. Yes, definitely. I also will review, and this will be very helpful for us. You okay? I can see that you have the UML.
Okay, I think there are 46 attendants and players are 37. So I think some of them still have to join.
So, Brooks, how's about your 100 days of code? How's going on?
Lots of discrete math. I'm trying to do the stuff that I feel like if you're a history degree holder that taught yourself how to code, the stuff you're probably garbage at is discrete math, like more hardcore discrete, data structures, algorithms. So always learning.
Excellent. I actually follow your every post in every day. What you are doing of your 100.
I always forget anybody actually pays attention to that stuff. It's just something I do now to kind of keep me make sure I try to actually. I'm a big believer right in that law of small improvements. If we can get a little better every day, in a couple of years that adds up.
Great.
Okay, I think we can start our quiz session now. 41 people have joined.
Yes. So any time limit, maybe?
Yes, per question there is 30 seconds.
Okay.
13.
13 seconds.
Okay.
Okay, so
Okay, let's go. So here is the first question. Which code follows the best practice? The answer is between A or B. Okay, I can see Ashish is first position.
Congratulations,
Shubhajit
Ashish.
is second. And
Okay.
okay, let's move on to the next question.
Just we will see the all of the result together.
Yeah. So Salesforce is a dash. Yes, obviously Salesforce is a CRM platform. So I think 31, 38 people got it right, and one of them just got it wrong. So let's move on the next question. So which of the following isn't valid for Apex programming language? Yes, so the answer is C, the weekly type. So 6 of the people answered A and 12 people answered D. So it's almost 50-50. So next, go to the next question. Which type of cloud doesn't exist in Salesforce? So yes, the most of the people got it right. The enterprise cloud, there is no cloud named enterprise in Salesforce. So here we can see Syed is first and Ashish is in the second and Shubhajit in the third position. So let's move on to the next question. Which class doesn't provide polymorphic behavior in Apex? Yes, the answer is B. So Syed is still at first position. So let's go to our next question. What kind of platform is Salesforce? SaaS, IaaS, PaaS, none of them. It's pretty basic question, I think. Yes, most of the people got it right. 27 people got it A, one of them D, and 2 and 7 of them B and C. So let's go to the next question. So the question is, which one is true? There are 4 options. Yes, the first one is the, sorry, the last one is the answer. And most people actually click on the first one. So Syed is still at first position, Saiteza at second, and Medha Shukla as third. Which isn't a relationship type in Salesforce? This is also another basic question, I guess. External, internal, lookup, master detail. Yes, most of them got it right. The answer is B. Internal isn't actually a lookup in the, sorry, isn't a relationship in Salesforce. So let's go to next. Which one is true for SOQL? Yes, B is the right answer. So Syed is still leading the answers in here. And I think this is the last question, the 10th question. There are dash types of polymorphism in Apex. 1, 2, 3, 4. Yes, most of the people got it right, the B. And if we go next, yes. So this is the list. Syed, congrats for winning the quiz. You are first, and the second position is Medha Shukla, and the third position is Ashutosh. So congrats, 3 of you, and those who didn't win, don't feel bad. You can
Yeah.
in a future.
Congratulations, everyone, and especially Said got highest marks, and he's a winner. Okay, so for Said, so waiting for voucher, right?
Yes, Syed, Meda Shukla, and Ashutosh,
Shukla and
three
Ashutosh.
people.
The three people will be get the voucher. Okay.
Yeah. So please write your WebSSO account's email address in the chat box. Syed, Meda Shukla, and Ashutosh, I am kindly requesting you to write your email address of your WebSSO account in the chat box. Thank you.
Thank you. We will wait for another few minutes for your email address, and then we will be closing our event. And lastly, actually, if from our attendees, if anyone want to talk for a few seconds, most welcome. In between, special thanks to Brooks Johnson joining with us, and really this event was very helpful for everyone who want to learn in deep and deep in the FS coding and yeah, object-oriented programming language. And for our
Yeah, thank you
community,
so much for
we
having me. Right.
welcome, and we will try keep continue our event again and again, uh, and yeah, be with us. So, Mehdi, did you got the email address for the winners?
And no, actually, I am still waiting for them.
Okay, later. Okay, I think later they can contact with us, and then we will send the voucher, right? Or
Yeah, sure.
yeah, we can and or we can contact with them. Okay.
Yes,
Yes, sir,
it
because
would be better if they put in the
yes,
chat
yes.
box.
Better to put in the chat. Yeah, it will be. So another more minutes. Here we are actually getting late. Already 10 p.m. in Bangladesh, Dhaka time. So winners are Said, Medha Shukla, and Ashutosh. Those are we need your email address.
I think it's getting late.
Yeah, I think we can close this event.
Yes, a huge shout out to Brooks Johnson for giving us your valuable time and knowledge. Hope to see you soon in future.
Yeah,
Yeah,
and
anytime. Thanks so much for having me.
yeah. We will try to have another session with Brooks. And everyone, thanks to everyone join with us and be still with us. Thank you.
Yes,
Thank
thank you very
you.
much.
Bye.
Thank you. Bye bye. মেহেদি থাকেন। আপনার কাছে তো এই ইমেল মানে যারা জয়েন করেছে ওদের ইনফরমেশন আছে না ইয়েতে কুইজে?
জি, জি,
আচ্ছা,
জি।
ওইখান থেকে আমরা নিজেদের কন্ট্যাক্ট করে পরে একটা আপনি কন্ট্যাক্ট করে ইয়ে করে নিন, হ্যাঁ? যেন মিস না হয় বা কোনো মিসিং বা কোনো ইয়ে না হয়, হ্যাঁ?
জি।
Okay, then ending, stopping recording also.